Welcome to BKSS Academy. Now we are discussing about Dempster shafer theory and one question related to it. The question is like this. Suppose two sensors, detecting the object. One object is detected by the sensor. So on the roads, suppose there are two sensors at two different locations. Sensor 1 believe the object is a car with 60% confidence, that is C, and aeroplane with 30% confidence, that is A. Sensor 1 is detecting the same vehicle 60% as car, 30% as aeroplane. Similarly, sensor 2, it is confident that 50% confident this vehicle as car and 40% confident this vehicle as aeroplane. So solve the problem with DST. This is the question. First we have to write theta of C and A. C is representing car and A is the aeroplane, and theta is the function defines all possibilities of the results. What the result? What are the number of possibilities of getting the result? So this is the function. In sensor 1, the first m1 of C is equal to 0.6 because of it is the 60%. m1 of A, it is 0.3 because of 30%. So rest 10% is there. So we can calculate uncertainty is m1 of C union A. m1 means mass function of sensor 1. C union A is equal to 0.1, which is uncertain, that the sensor 1 cannot identify. That is because of 10% it becomes 0.1. Similarly, in sensor 2, mass function of car is 0.5 because of 50%. Mass function of A is 0.4 because of 40%. Rest 10% is there. That is mass function of sensor 2 C union A is equal to 0.1 from this 10%, which is uncertainty, which is the result is giving uncertainty. Then we have to calculate joint mass assignment by multiplying the overlaps. That means from sensor 1 and sensor 2, for sensor 1 that mass function was m1, sensor 2 mass function was m2. So we have to calculate the joint, that will be m. So m of C, the formula is like mass function of car from the both sensors, that is m1 of C into m2 of C plus m1 of C into m2 of C union A plus m2 of C into m1 of C union A divided by 1 minus k. This is the formula for car, mass function of the car in both the sensor camera. So result, just putting the values here, 0.6, 0.5, 0.6, 0.1, 0.5 into 0.1. 0.1 is M1C union A, 0.6 is M1C, 0.5 is M2C. What is, we are already calculated these functions. Divided by 1 minus k. This k is the conflict factor. What is conflict factor? There is a formula, that is m1c m2 of A plus m1 of A into m2 of C. m1 of C into m2 of A plus m1 of A into m2 of C. So that will be calculated as by putting the values of m1c, m2a. So that will be like 39, and 1 minus k will be like 1 minus 0.39 will be 0.61. So by putting the values at m of c, that will be 0.41 divided by 1 minus k, 0.41 divided by 0.61, because of 1 minus k is this. Okay, then its result will be just like this one, 0.67. Similarly, mass function of A, the formula is m1a into m2a plus m1a into m2 m2 of A union C, m2a into m1 of A union C. So this is the formula, divided by 1 minus k, divided by 1 minus k. As we know, 1 minus k is equal to 0.61. By putting the value of m1a, m2a, m2a union c, m1a union c, we are getting the value, that is 0.19 divided by 0.61, which will be like 0.31. So m of A union C is equal to 0.1 divided by 0.61. That means m of A union C formula is like this, 1 minus k. So this will be the result of mass function of A union C. So final belief will be mass function of C will be 67% because of this 0.67. Out of 100%, we will calculate that will be 60%, 67% car. Mass function of A, which is belief, is 31 aeroplane. That means the result is 0.31 and we are getting the result 31. So mass function of A union C will be 2, 0.02, it will be 2. So what we are observing here, before it was maximum range was 60, it becomes 67, and its maximum range was 40, it decreased to 31. So this will be my exact answer, that what that vehicle is. Thank you. Have a good day.